Welcome back, Year 8 students. We are continuing our work with algebra, and today we're looking at solving worded problems using algebra. Um, look, when we come across worded problems, particularly in algebra, a lot of students get a little afraid of them, or I guess are worried by them because they do generally find them quite difficult. So what I want you to do is obviously do your best with worded problems. You will always have a lot of variety with them, and I guess that's where they can be challenging. There's no one step or one very clear step-by-step process that you can follow for every worded problem. Each one is different. In this video, I'm going to show you just four problems. So that you get an idea of, I guess, a variety of different ones, but also just so you can see some strategies that you can use to solve them. So our learning intention, it will be to write an equation to represent a real life problem, because it's only once we have that equation that we'll then be able to use our solving methods that we've done already in this unit, and then we'll be able to solve the problem. So the second intention is that we then solve that equation to find the solution. So the trickiest part, of course, is to write that equation. So that's really, I'm going to underline it because that's our most important part. In terms of your success, well, if we have a look over here, there is a way that you can know that you've got the right answer. So once you have actually solved it, you can check your solution actually fits with the problem given. So you might have a certain number of things that are told to you, or mentioned in the question. So it might be, say, that two particular numbers add to a particular result, or you might be told something else, and basically you're looking at that and you're working out whether your solution works with that information that was given. I'll show you what I mean by this first one. The problem is that I start with a number, I multiply it by 3, then I subtract 8, and the result is 7. Find the number. So this one is actually similar to ones that we have already tried a little bit in this unit when we were solving a couple of worded questions that we did. So I thought I'd start off with something basic like this one. I start with a number. Now that's the number that I'm trying to find here. So I'm going to label that as X. Might just write it down here. It then says I multiply it by 3. So you're tempted to do this, but remember in algebra, we don't write that multiplication symbol. We write the 3 out the front. So multiplying X by 3 is 3X. Then I subtract 8. So I'll take away 8. So after it's multiplied by 3, it's then subtracted, or the 8 is then subtracted. If it was the other way around, if 8 was subtracted first, it would be like this. And if it was then multiplied by 3, I would put that in a bracket to make sure that the X minus 8 was multiplied. But of course, it wasn't given in that order, so I'm not going to do that this time. The result of this, so the result of multiplying by 3 and then subtracting 8 is 7. So another way of saying the result is that it's equal to, and then I write the 7. Find the number. So now what I want to do is find X. So I'm going to add 8 to both sides, like so. That leaves me with 3X on the left, and 7 and 8 is 15. What I'll then do is divide both sides by 3. So a lot of you are getting to the stage where you don't need to write 3 over 3 like this. You can still do that, but lots of you, I've noticed, are getting to the point where you recognize that X has to be 15 over 3, and so you're writing X equals 5. So that one is on the easier side. Of course, when you come across these, you have to still read very carefully. Something like this that's only a couple of sentences, it's still, I guess, fairly common for little mistakes to be made, especially with the bracket that I mentioned before, say if this was written the other way around. So that's our first one. The second one is getting a little bit trickier now, and there's a couple of terms here that we need to know. So two consecutive numbers sum to 31. First of all, I want to know what consecutive means and I want to know what sum means. Now, sum is one that you've heard of probably many times before. That's when we add numbers together. We can say when two numbers are added together, we get 31. That's another way of phrasing it. Consecutive numbers are those that are, I guess, on a number line. They're side by side or they differ by one. So if I do a little brief number line here, just say I had 7, 8, and 9. That means that 7 and 8 are consecutive and 8 and 9 are consecutive because there's only one difference between them, or if we were doing integers on a number line, they are next to each other. So I'll just remove that because we don't actually need that for this problem. Okay, they sum to 31. Find the two numbers. So what I'm going to do is just say that when I take my number and I add it to the other one, the two numbers, the sum of them has to be 31. I'm starting off with that equation because that's probably the most obvious one here. My two numbers are x and y because I don't know what they are, but they have to add up to give me 31. Now, the other thing that's important here is that they're consecutive. Now, remember I mentioned before that consecutive numbers have a difference of 1. That's important here because say x is the smaller one. That means that y, my other number, is just one more than x. It's the very next number on the number line. So what I can do is I can actually say that y is the same as x plus 1. It has to be because they're consecutive. And if I know that y is x plus 1, what I'm going to do is I'm actually going to write x plus, and instead of writing y, I'm going to write x plus 1. Because when I add this one and this one together, I have to get 31. Now that I've done that, I actually have an equation I can solve. Because I can't solve this one up here, x plus y equals 31. I don't have enough information. I can solve this one though, because I've got two terms that are like terms. So this is 1x, and that's 1x there. So of course 1 plus 1 gives us 2, so 2x. Then I've still got this 1 here, plus 1 equals 31. Now that I've collected the like terms, I'll take away 1 from both sides. So 2x equals 30. Finally, x must be equal to 30 divided by 2, or if you're doing it this way, we've divided both sides by 2, so x has to be 15. Now, if x is 15, we know that y was x plus 1, so that's 15 plus 1. Our y value has to be 16. Now, what we can do is we can check if this works. So obviously the consecutive numbers, yes, that's clear, 15 and 16, but do 15 and 16 add up to what we need them to add up to, which is 31. 15 plus 16 is 31. So I know that these are my two numbers. So just make sure your answer's nice and clear. I've got my two numbers at the bottom there, but I'm just going to write the two numbers. Actually, I might put the two numbers are 15 and 16. Now, you might have been able to get this answer by trial and error, but remember the point of us doing this is to make sure we're using the algebra. So it's really important that you do try at least to get your equation rather than just going straight to a trial and error approach. Okay, I've got two left. This one here it's I guess a little similar to the previous one in that we're talking about two different numbers and there's certain criteria that we know about those numbers. So the sum of two numbers is 30. You might recall what we did last time when we had a sum of two numbers. We went x plus y and we said that's equal to this result up here, or we're told that it's equal to 30. Now this second one of the numbers is double the other number. So what I can do, similar to before, this number here, my second one, has to be double the other one. So that means that y is the same as 2 lots of x, since timesing by 2 is doubling. Now what I'll do is, instead of writing y, I'm going to write this term 2x, because I know that y and 2x are equal. So x plus 2x equals 30. Just like before, I'm going to now solve. I need to collect these like terms. I've got 1x there and 2x here. So 3x equals 30. So x must be equal to 30 divided by 3, which is 10. Now that we know x, we know that y was equal to 2 lots of x. So y has to be 2 times 10. And that is 20. So our two numbers are 10 and 20. So they add up to 30 as was required, and one of the numbers is double the other number as was required. So that's what I mean by your success criteria. You'll know that you've got there when the two numbers that you've solved for, they are they are following, I guess, this criteria or this information. They fit with that information that was given. I wanted to finish off on one that is a bit more challenging. So already just by looking at how many words are there, that indicates it's a little bit harder. It's going to take us longer to read it, longer to decipher, and longer maybe to create our equation. So this one involves an average. We've got Callie playing 3 games of football, and she scored 5, 9, and then 2 goals. Respectively just means that it basically means in each of those 3 games. So 5 was the first game, 9 in the second, and 2 in the third game. How many goals must she score in her next game, so in her 4th game, to ensure that an average of 5 goals was scored per game? So in other words, if we look at her average goals across the 4 games that she will play, we want her average to be 5. Now think about what an average is. It's the mean. The mean is the sum of the values, and it's divided by the number of values. Oops, that's not very straight. Okay, so that's what our average or our mean is. Now, if you think about it, we know that the sum of the values, we've got part of the sum because we know that 5 was the first score and 9 was the second score, and it was 2, wasn't it, for the next? I'll just double check that I did that. Yeah, 5, 9, and 2. So that's what she scored so far. The sum of the values, that's actually going to include what she scores in the next game, and that's what I don't know. So I'm going to call that X. So this is, I guess, not an equation just yet, but it's an expression that adds up the sum of all of her goals in her 4 games. If we were to find the average, though, we would then divide that by how many values we have. And as we can see, there will be 4 of the values, 4 values altogether. Now, when we do that, we want that average to be equal to 5. It says up here, average of 5. So I want this calculation to equal 5. At that point, I've now got an equation. It looks really big and complicated, but we're going to simplify it to make it easier. First of all, on the top, I've got like terms here, the 5, the 9, and the 2. Let's add them together. We get 16, and then we've still got x to be added on as well. That's still going to be divided by 4, and that still needs to be equal to 5. With my next step, I see I've got something on the top here being divided by 4. So what I'm going to do is times both sides of the equation by 4. That, again, is just doing the opposite to what is happening on this left-hand side of the equation. Divide by 4 is what was happening, and times by 4 is the opposite. That will allow, just get my colour I had before, that will allow me to now cancel out these 4's here. It will leave me with 16 plus x, and on the right-hand side, 5 times 4 is 20. And now we can probably see our answer. We want to take away this 16 from both sides. That leaves us with x equals 4. 20 minus 16 giving us 4. So what this is telling us is in the next game, Callie will need to score 4 goals so that she has an average average of 5 goals per game. Let's have a look if that works. So if x is 4, we'll add it up. We've got 5 and 9 is 14. 14 and 2 is 16. 16 and 4 is 20. 20 divided by 4 is 5. So we know that our answer to this worded problem is correct because it fits with the information that was given. Now, remember what I said at the start of the video, every worded problem is different, and that's where practice with them is essential. You really want to practice with a variety of different problems so that you can see the different strategies that you might have to come across, might have to use in those questions that you come across. So we'll have plenty of time to practice this in class. We'll have some lessons. We'll have a lesson next week as well. So I'll stop the video here so that we can continue with that practice.